In lesson 1, module 3, this section is called integer exponents. For the sake of this video, though, we're going to skip the opening exercise, the exploratory challenge, and example 1, and we're going to start with example number 2 found on page 3. We're going to focus on the integer rules when it comes to exponents. While I'm going to bring some up, if you do need a guide at the very end of this section, they do have in the lesson summary each of the different rules that we're going to look at, and so there's 7 of them, and so just be aware of where those are at. So I'm going to model example number 2, where it says they want us to multiply 5x to the 5th power times negative 3x squared. So the rule that's getting put into play, just to make that note, is if I have a base, we'll just call it A, or we'll just call it X, I guess, and it's raised to a power, and it's multiplied to the exact same base with a different power, or same power, then all you're going to do with those exponents is add them. So that's what we're going to model in this first example. Now, the big numbers, the coefficients, the 5 and the negative 3, there are no special rules here. 5 times negative 3 is negative 15. That doesn't change. So now I've got x to the 5th times x squared. Since they're both a base of x, I can add the exponents. So 5 plus 2, and I get 7. So same thing, kind of idea happens with division. Here we see 3x to the 5th divided by 2x to the 4th. We also got a power rule in here. So there's multiple things that happen. So one of the rules is if I've got something inside of a power, so let's say we call it an x. And let's see, we'll put a little a on here. And it's raised to a power. So this is a power raised to a power rule. That means we just take those exponents and we just multiply them together, a times b. Also a rule at play here, it's going to be a division rule. So if I've got, let's see, a power, and I have a division by the same base with a different power, then all I'm going to do with those is subtract those exponents. So now if we apply these rules, right? So first we'll apply this power rule. So 2 times x, and we have everything raised to the 4th power. So that means our answer in the denominator is going to be 2 to the 4th power. And we can calculate that, and I would just recommend you grab a calculator if you don't know what that is. So 2 to the 4th power is 16. And then 1 times 4 is 4, so you get x to the 4th power. Now again, for coefficients, they're just coefficients, so I can simplify if possible 3 over 16, but 3 doesn't go into 16, so it's going to remain as 3 over 16. But what I can do is I can do 5 minus 4. That's this division exponent rule, and so we end up with 3x over 16 as the final answer, right? And so now for the next rule, again, we have 2 rules occurring in this example. We've got a power raised to a power, so we'll emphasize that one. So one of the rules is we have a power raised to a power, which means we just take those 2 powers and multiply. And then we have a case where we have a negative exponent. So if we have a negative exponent, the rule that applies, whether it's in the numerator or denominator, so if I have a negative exponent, so we'll say x to the negative a. If it's in the numerator, if we switch it to the denominator, it makes the exponent positive. Now this works whether the exponent begins in the numerator or if it begins in the denominator. You would therefore just move it to the numerator. So now if I do this, right, so I leave the 3 alone, and then 2 times negative 3 is x to the negative 6th power. And if I wanted to get rid of that negative exponent, because it's in the denominator and it's negative, I can move it to the numerator, and that makes it positive. And so that ends up being the end of that answer. So in part D, we see multiple rules occurring again. And one of the rules that we'll use in D is if I've got a base with a power multiplied to the same base with a power, we are going to add those exponents. And then we're going to also use the case that if I've got a piece in the numerator and I've got a piece in the denominator as the same, then we'll end up subtracting those rules. And depending on how it looks, we may end up using another rule, but we're going to wait and see. So they say negative 3 plus 4, that's going to be x to the first power. And then I've got x to the 8th in the denominator. And so 1 minus 8 is x to the negative 7th power. Right, so we're going to leave it at that because in our instructions it said to write everything in the form of kxn squared. And so we can see that idea in each one. The negative 15 is our k. This is our x to the n power. This 3/16 is our k. Again, we have our x to the nth power. N is 1 this time. Here's our k. Here's our x to the nth power. And again, our k here is a 1. And we see our x to the n power. In this case, n is negative 7. So again, before we do the exercises, you might want to take a moment and just review these rules again. Read through them. Many of them we already highlighted. So for example, I already highlighted number 1, number 2. Number 2 and 3 is essentially the same rule. We just highlighted number 4. We've done number 5. And 6 is essentially the same as 2 and 3. So the only one we haven't come across is anything to the 0 power is 1. So we'll put a little circle by that one. We haven't shown that one yet in that exact capacity. But you do want to review these and know these for the assessment. So let's see. Here are our questions, obviously not typed up, but that's okay. So this is exercises 1 through 5. And so if we apply our rules, 2 times 1 is going to be 2. And then our x is going to do 5 plus 10. And we get 10 to the 15th power. And remember, our goal is to write everything. I should mention that because the direction is not on this page. Our goal is to write everything into a k, a constant in the front, with an x to some power, whether that power be positive or negative. So if we try and do that with this one here, right, we see 1/3. And what we're going to do is we're going to move that x to the 8th to the numerator, and that's going to make it negative. Here we're going to subtract, so negative 5 minus negative 3. So negative 5 minus negative 3, that gives us negative 2. So this ends up being 6 times x to the negative 2 power. Here we have everything raised to a power. So what happens first when we do this, right, we could say 3 to the negative 3rd power, and then negative 22 times negative 3. And that's going to give us x to the 66th power. Now, if I want to, I can move that to the denominator. So now I end up with 1 over 3 to the 3rd power. Remember, if you move from numerator to denominator or vice versa, it changes the signs. So now I get 1 over 27 x to the 66th power. And if I'm trying to match my k times x to the n power, this would be 1 over 27. And then I'll have to move this 66 up to the numerator. And that would make it negative 66. And so this one, if I wanted to go with this, this is a power raised to a power. So we end up with x to the 2n times x to the third currently. And then to wrap this up, since the base is the same and I add, it becomes x to the 2n plus 3. So that is going to be the main purpose of lesson 1 in this new module. This new module is all about exponents and power rules and things like that. So it's very different than module 1. So after you've accomplished that, you can take a look at the problem set accordingly.